Hey everyone, Professor Saxe here. And in this video, we're going to explore more about atmospheric lifting and precipitation, specifically with a focus on the four principal types of atmospheric lifting. And I would encourage you, if you haven't already done so, to go back to my video on the adiabatic processes, because we need to understand how when air rises, due to these different lifting mechanisms, it will cool, and it may cool to the dew point temperature or 100% relative humidity and form clouds and potentially precipitation. So if you have not watched that video, because those processes really come into play, please go back and view my video on the adiabatic processes before you watch this video. What are the four principal lifting mechanisms? Our first is convective lifting, and this is typical on a hot summer day in certain parts of the United States where you have unequal heating, and air near the ground becomes warmer than the surrounding air. As that air warms, it becomes more buoyant and lighter, reduces its density, and it is caused to rise. And that rising air can then form clouds. Again, if you remember nothing else in this video, just remember that for each lifting mechanism, I'm going to beat it to death in this video, you have to have air rising and cooling in order to have these precipitation processes. So now we're just trying to define what are the different things that can cause the air to rise and perhaps form precipitation. So here it's the unequal heating that causes the lifting of air, where that air is going to cool, condensation can take place, and potentially precipitation. And if these air parcels start to join together, here in this picture, we just have a bit of a pop-up storm, which is typical and common in the summer months in the Midwest or in the Southeast, where there's just been so much heating over the course of the day that in the afternoon you can get a release of this energy through precipitation, but it's very localized. However, these convective cells can join and form larger cells. So when those multiple cells form, you could get a larger convective precipitation cell, and then it becomes still probably localized, but a larger storm than what you're seeing here in this picture. And again, we'll find it in the warmest parts of the world where you just have that intense heating taking place. But in our United States, commonly in the summer months. Our second type of lifting is orographic. And here we looked at this again in the video on the adiabatic processes. But our large air masses, the lifting mechanism here that forces those masses to rise is the topographic barrier. So as this air rises, as it encounters a mountain range or some geographic feature, orographic precipitation may occur. So again, air is rising. As it rises, it's going to cool, where it can cool to the dew point temperature, where it will change from water vapor to a liquid, and then perhaps into some form of precipitation. We talked also in the adiabatic processes video about how when if the air is coming in from it depends what side that air is coming in. When it reaches that mountain range, one side will receive the precipitation, but the other side, or the leeward side, this here's the windward side, but the leeward side is going to be dry. And that gives us a rain shadow effect, where we have more desert-like conditions on the leeward side of mountain ranges. You see that here in this image where you have your Sierra Nevada mountains. Moist air in the westerlies coming over the Pacific Ocean is going to cause the precipitation to be released before getting to the other side of the mountain. And then as air descends and warms, it will reduce its humidity and you get drier, warmer air. That's orographic lifting. What about frontal lifting? We see this quite a bit also in the United States. When you have unlike air masses, they are not going to mix. They're going to form a zone of discontinuity that we refer to as fronts. And you may have heard this quite a bit when you watch the weather. Cold fronts, warm fronts. What does this mean? Well, it means that in other cases, but in this case, our lifting mechanism is the difference in the air masses, primarily the cool air, which is heavier and more dense and will stay close to the surface, where that warmer air is going to rise above the cooler air. So we're going to go into a lot more detail on this when we get into atmospheric disturbances. But for now, you'll just need to know the warmer air rises above that heavier, cooler air. What does it do as it rises? It cools. It may cool to the dew point temperature, and then it may form precipitation. And here you see an image of this. You might be more used to seeing something like this in the news, where you'll have warm air coming up from the south, cold air coming down from the north, and this mid-latitude cyclone will also explain more in a later video. But there you kind of see it in the real world. What does that look like? And so you might have some more familiarity with it. This one is going to be most significant in the mid-latitudes where dissimilar air masses are found. If you're in the poles or you're in the tropics, you either have pretty much all cold air or pretty much all warm air. Those two air masses, you don't have what you need in order for the warmer of the two to rise above. So we're going to see that mostly in our mid-latitudes. Finally, we have our convergent lifting as our fourth lifting mechanism. And what's happening here is air masses may collide, and the uplift is because there's just not enough room and there's crowding between similar air masses. And as you see here, air mass coming from this direction, air mass coming from this direction, and the crowding just forces them to rise. A good example of this in the real world is at our intertropical convergence zone, where you have like air masses, both warm, both wet, coming off of the oceans and meeting together in the trade winds and being forced to rise there. So this gives us enhanced instability, possible convergent precipitation, and can be the root of many cyclonic storm systems and tropical disturbances. Again, these are characteristic of the low latitudes where you have the trade winds coming into contact in the ITCZ. And those are our four lifting mechanisms that can cause precipitation. Thanks so much for watching.